Hi, Gabriel. Thanks so much for joining me today and contributing to this interview series that we're calling the Pioneer Series. We set up these conversations because we felt that this field of data, machine learning, AI is still relatively new, right? And more than being new, it is evolving and changing really, really fast. And as a result of all of that change, there's no kind of manual or like set pieces or accepted practice about how businesses and organizations adopt this technology, embed it, get the most value they can from it, in a safe way, and all of those kind of concerns. And so, yeah, we want to talk to people that have been at the forefront of that field, adopting the technology, and solving these kind of hard challenges, right? So it's a real pleasure to have you on the series today. You're currently Chief Data Scientist at Ocado Technologies. So Ocado Technologies is kind of a platform which enables like really scalable kind of grocery deliveries, and from a kind of e-commerce to point of delivery. I'm a customer, and it's like from a data perspective, from a technology perspective, I don't think you could have a more kind of interesting stack, right? From acquiring customers to the customer journey, customer experience, e-commerce. But then beyond that whole e-commerce thing, it's like really interesting, right? In terms of how you're fulfilling that. You've got robots, computer vision, a very interesting kind of logistical set of challenges, operational set of challenges. So super interesting work, I would imagine. So it's really great to have you here today. I know you kind of started off studying maths at university and went into management consulting, but how did you get into data? How did you get into machine learning?
Thanks a lot, Ed, for having me. Really looking forward to our conversation. I have to be honest, I almost fell into it bit by coincidence. So I worked as a management consultant, as you said, for a couple of years in the Middle East and in Germany, and decided to go back to the UK and do an MBA. And during my MBA, I got on really well with one of my professors who was doing operations research. And he introduced me to someone who had been building like operations research stuff and forecasting algorithms and something like that for Tesco. And at that point, they were starting to build a new program to do demand forecasting and order optimization for general merchandise. And they were looking for someone who could help build up that team and to do the translations between the maths, so kind of the algorithmic side and the business side of it. And it sounded something really interesting to me. I wanted to do something that was a bit more kind of technological and a bit more kind of practical, if you want, after my consulting times. And yeah, so I ended up more or less coincidentally working at Tesco and continued building that team there for a couple of years, and kind of extending what the team was doing from demand forecasting to lots of applications over time.
Wow. And so what year was that? Because Tesco was really at the forefront. They invented, many of the kind of early notion. I mean, as my understanding, they invented the loyalty card. They were really at the vanguard of kind of data in terms of driving efficiencies and better customer experiences.
Yeah, so Clubcard started before Google was formed, and in the 90s already, Tesco did a pretty good job with demand forecasting, especially our groceries. They had done less investment into general merchandise, so that's where I came in. That was about 10 years ago. It's quite a while now.
So general merchandise was what was the data challenge there?
So general merchandise is products that have a longer lead time. So, you have to bring in your TVs and electronicals most of the time from China, so it's about 6 months. They sell significantly less than a can of baked beans. Like you might sell one or two TVs in a big store. And that kind of means that your patterns are a little bit different. So you need to be able to forecast lower demand products, but you also need to be able to deal with a much longer lead time. So that was kind of the big distinction compared to grocery items.
Okay, right. So it's like a really different, high value and kind of high costs, I would imagine, but slightly harder to model kind of statistically.
Yeah,
So,
exactly. Your trade-offs, like, but on the other hand, they don't go off, right? So it's not like a can of
right.
baked beans that you can only sell. Well, actually, that's a bad example. It's not like a salad that you can only sell for a couple of days. It stays good much longer, but then at some point the trend changes, and you might not be able to sell last year's iPhone quite as well as this year's, for
Okay.
example.
And was that like the first production? I mean, always interested. What was the first time you got a machine learning or a data science system into production? Was that the problem for you?
Yeah, so we were forecasting about 40,000 products across, hundreds of Tesco stores up to six months in advance. So it was a quite complicated system from forecasting perspective alone. And then it was a multi-echelon optimization problem. So Tesco's stores get their demand from a distribution center. So you kind of you model the demand on the store that then gets kind of contributed back to the distribution center, and then you try and figure out when are you going to order from which supplier, how many cases. So it was really, really interesting way to learn about production machine learning at scale.
Wow, yeah. And were there any like mega kind of gotchas or something that you were kind of it's interesting you came into it through operations research, I guess, because that is so practical. But a lot of people come into this from stats or maths backgrounds or computer science backgrounds, and when you encounter your first real life problem, you're like, oh, this is thorny. There's so many more constraints and real life considerations. I don't know, was that an experience that you had there?
Yeah, I think kind of what was interesting is 10 years ago was about the time when neural networks were starting to slowly resurface, but not yet properly, right? Like it was kind of, I think, more of the dross in the deep learning time. And so while we looked at that stuff, we actually figured out that putting more effort into data manipulation upfront was significantly more valuable. So the machine learning models themselves were fairly simplistic. They were kind of multi-level regression models, but we put a lot of effort upfront into the data aspect of it. I think, to be honest, though, for me, the bigger things I've learned was around like how do you run a program of that size, or how do you organize yourself? Because back then Tesco was still fairly kind of traditional IT, so it was fairly waterfall. So you had to define all of your data requirements up front. You would then, in inverted commas, throw it over the fence to the IT department that was still called IT back then, who would then deliver on it. You then looked at the data and you realized that the quality wasn't quite there, and stuff like that. So it was actually quite hard to deliver something like this that fundamentally where you didn't quite know yet what data was valuable and how quality could be measured and stuff like that. So I think I learned
That's
probably more about that aspect of it than anything else.
Well, that's so interesting, right? So it's like that the traditional kind of software lifecycle, that whole kind of way in which software was developed and released in this kind of legacy environment being quite waterfall, just didn't match up really with the requirements of what you needed in this kind of test and learn. Was that one am I hearing you right? You wanted a more iterative framework to kind of put the best model forward, see how it did, and kind of iteratively calibrate.
Yeah, there was a lot of design going up front. Is that look, this is how we're going to build the system. Then we brought in external help. We were writing all of this in bespoke software. So it was actually also really hard to hire people with the right skill sets, because it wasn't necessarily the language that everyone learns at university, or that is the most common language used across other industries. So yeah, there was lots of different interesting challenges that I've definitely since then tried to tackle differently.
That's so interesting. And so, did you actually change the way in which software was released? Did you like get a model in place which was more agile, or did you have to get your program of work to fit within that more waterfall approach that was already in place?
So on that project itself, we weren't able to change that anymore. It was more for subsequent projects where we were trying to be a bit more getting something out faster, using more open source software, so switching more towards the Python direction, hiring people much more based on kind of their ability and attitude towards being able to solve problems than necessarily based on specific skill sets related to a specific problem domain. So yeah, I think it changed over time, but not on that project itself.
Yeah, okay. So it's like the two things I'm here is like the quality of the data and ensuring that am I right? Like it's like the two big lessons, like the way in which like the two most important things were the quality of the data coming into this thing and getting that in a really good shape, and then the second piece is a framework for it to be more agile and iterative to refine and um,
Yeah, and I think for me, this has been one of the biggest learnings throughout my time in the spaces. I think at the beginning, a lot of the focus was on solving a data science problem, and that was kind of hard. But fundamentally now, right, like there's a lot of AutoML tools and all of that stuff that has become significantly easier. The second challenge we then had to figure out is how do you solve a data science problem at scale when you have a lot of demand against your service or you have a lot of data. But even that's kind of getting easier and easier now because you have tools like TensorFlow or kind of other cloud things that allow you to build this relatively simply. So now the thing that I think is the most difficult one is how do you scale your data science organization and how do you scale your approach to data science? And that's definitely where most of my learning has been and where it's probably been the biggest changes I've implemented for the last 10 years.
That's super interesting. That's super interesting. And then I guess from that first experience of getting something live and in production in an industrial at scale kind of context, how about today? Like, how's machine learning embedded in the work you're doing today?
So one of the things that, as you mentioned, that's really interesting around Ocado technology is that we have technology across the whole end-to-end of the grocery e-commerce lifecycle. So we use machine learning in the front end to help you select which product is the most appropriate and most exciting for you out of the 50,000 or 60,000 products that are available on the website. We then use machine learning to try and figure out which slots should be available for you and in order to get the vans to you in the most efficient way, right? Like it's good from our perspective because it saves costs, but it's good from an environmental perspective because it saves petrol and stuff like that. We then also use machine learning because we have all these robots that are whizzing around on our grid. And so, the way that those robots move around is based on top of a lot of pretty impressive simulation. But we also have something in place where we use vision systems, etc. If something does go wrong, which happens every now and then, we can spot where the robot is stranded, and we can generally also spot which robot it is. And then kind of that makes the engineering part of it simpler. So it reduces the cost of operating quite a complex system. So, and to be honest, that for me was one of the key things that I found exciting about Ocado Technology is that diverse use of machine learning that I think is quite unique towards the retail businesses.
Yeah, and also like those two, it's almost going to be what I was going to say next. Is like, how do you perceive the value of what machine learning can bring to an operation, to an organization?
Yeah, I think kind of retail has been always more at the forefront of machine learning, I think for two reasons, right? Like retail, it's fairly easy to track because you have repeat customers, what the value is. As in, I can show you that by using a recommendation engine, it increases the adds to basket or basket size, etc. But grocery retail as well has been super low margin in general, right? So taking out costs out of the operations has been always super easy to then make an argument for. And so from that perspective, for a lot of the stuff that we do, we can either track the benefit it has on kind of customer retention, higher basket sizes, whatever it is, or we can track it in terms of the cost of the operations and improvements in efficiency in that space. And so that makes ROI tracking in that space almost easier than in some other industries.
Yeah, it's cool. And like, so like I always think, you know, um, efficiency arguments also they're not distinct things, right? If you have more margin, that feeds directly into growth, right? Because
Yeah.
it feeds into growth in multiple ways, right? It gives you more cash to acquire customers. You can acquire customers better. You can sell your products cheaper than your competitors, and therefore also drive acquisition that way, right? So there's when you're is that how like traditionally investments in this kind of stuff have been made in your like not just where you're today, but throughout your career? It's like how do people are you making kind of ROI cases based on efficiency saves, or do you have like kind of sophisticated models that also factor in the growth narrative?
So I think it really depends on the industry, but I think kind of Ocado Technology is interesting because we're a B2B business. So we sell platforms to other retailers around the world. So we can, and fundamentally, the metrics that we care about on the basic level is fairly simplistic, right? We want to make sure that once the customers get to the platform, the experience is as good as possible, so that our retail partners can have satisfied customers and high sales. And then there's aspects of the operation that end up being costs to us, and we're trying to minimize that. And there's aspects of the operation that are costs to retailers, and we're trying to minimize that as well. So from that perspective, it's fairly straightforward ROI cases in many cases. I think as you say, kind of the growing demand is always a little bit more challenging. How do you account for that stuff? Because like the demand isn't necessarily profitable in some industries, right? So I think kind of you need to take them into account at both sides.
Um, and then also there's like kind of cookie cutter applications of machine learning where you know the technology is going to work, and then there's just a simple ROI calculation. But then there are these other applications where we have to try. It's true R&D, right? We have to try. We have to make this investment. We believe that it could work or it will work, but we don't know that it will. That's so often the case in a kind of more exploratory data analysis, right? That you have to put the investment in with no guaranteed success. Is that something you encounter a lot, or?
Yeah, so I think there's definitely certain areas that we know will always be important to us, right? And therefore it's easy to invest into that thing. So we know that we have a massive amount of products and we want to make sure that customers find them as quickly as possible. So kind of investing into broadly product discovery always makes sense. There's other areas as well where kind of, again, it's a big part of the operational costs. So therefore investing into making those operations better and more efficient makes sense. We might sometimes not know what the right approach to it is, but we will generally know that there's value to be gained there. And so we will maybe at the beginning invest a little bit, try and see, okay, which ones out of these different approaches make sense. And then as we kind of narrow down on a more promising approach, we can then scale up the investment into that space.
Yeah, that
So you
makes so
can,
much. If you have a big block of cost, or you know that there's something sizable there, it just makes sense to attack it, right? You don't know what the exact opportunity will be, but you have to invest in it. And as you find things that don't work, you're kind of narrowing down the.
yeah, exactly. I
Yeah.
mean, vehicle routing is one of these typical ones, right? Like vehicle routing, you will have to do it. A big part of grocery delivery to people's homes is to bring the stuff to their home. So kind of it makes sense to invest into something like that and make those as efficient as possible because you know it will always be a cost aspect of your business.
I mean, you say obviously, but I think that's more a consequence probably of the culture of the firms you've worked at. There's a lot of places where people have huge cost bases and don't apply that analytical rigor or that data-led approach to attacking those things. But yeah, that's super interesting. And then this field is changing so quickly. I mean, I've been here working in this space, I think, for 10 years or something. Something feels it is different now, right? I mean, I don't know how you think about that. Like, how have your views on machine learning and AI changed over the last like 2, 4 years?
I think there's a few different things that have changed. I think in the past we've talked a lot more about kind of the metrics of success being related to accuracy. And I think that's changed a little bit. I think kind of data science or machine learning was much more academic. So most of the papers you would look at, sorry, were related to basically training something on a toy data set and trying to beat each other. And I think there's much more of an appreciation that in the real world, the constraints might be a bit different. And so actually the metrics that you need to look at is probably not just accuracy. There's probably an aspect of how easy is it to put this out? How easy is it to change it? There's obviously also much more discussion right now about like, well, what's the responsibility angle in this? Is it going to create a fair result for all your customers or all the stakeholders in this stuff? So I think that's changed a bit. Obviously, kind of also AI has been massively more prominent in literature, etc., right? Like, and fictional literature as well as kind of in the press. And I think kind of you now get in this weird world where while responsibility is definitely a sensible thing for us to think about, AI has almost become like AI is responsible for fake news and stuff like that, which I think is fundamentally not true, right? Like it's business models that are using AI in a way that is responsible for fake news and things like that. And I think kind of getting back to a discussion that's a bit more nuanced around the benefits and the cost of machine learning, but again, also talking about the benefits, um, is the other thing that I think we're going to see over the coming years as well. So it was like AI is all amazing. Then there was a time of AI is really scary and it's going to destroy our world. And I think now we're getting towards this world where it's like, well, AI has like any other technology has its pros and its cons, and you need to know how to use it, and you need to make sure that you have the right risk management in place. But then actually it can be super beneficial.
Yeah, yeah. Yeah, and like that accuracy thing, it's so true. It's like I don't think. we are over that hump fully, right? There are people that are,
Yeah,
are really at the forefront of implementing these things, and they know, like, it's almost like thinking about a car only in terms of what's its max speed. It's like that
yeah,
is not how you buy a car, and if you did, you'd end up with some sort of Frankenstein that you could never ever use.
yeah.
Yeah, so interesting,
And I
and
think there's still some work around, like how do we get broader stakeholders to understand the differences between traditional software engineering and machine learning based software engineering as well. So I think that journey has evolved a lot as well.
evolved a lot, but still so early. I think we
Yeah,
see that especially in some of these kind of more legacy environments where it is a real waterfall approach, right? And UAT, dev, and test. We operate in environments where UAT can't have production data. So
yeah.
it's like, well, that invalidates that invalidates machine learning. I mean, if you can't have production data in UAT, I don't know. It's like there's a problem there that needs to be worked through. Um,
Yeah, and testing for machine learning applications in general is an interesting question, right? Like how do you do that in the right way?
yeah.
How do you make sure that you test the performance over the long term? What kind of metrics can you figure out upfront before you put it live? But then also, how do you keep a good understanding of your model drift and data drift and all of that stuff? And I think there's just not yet the platforms in place either. There's obviously a lot of investment by cloud providers to make that easier, but we're nowhere near in the maturity as we are with software engineering more broadly.
Yeah, nowhere near, nowhere near. And I guess you've had to build a lot of that stuff yourself from scratch, right?
Yeah, so we have internal teams that are building kind of our own ML platforms and stuff like that. I think kind of we're also in quite a unique space the way that we develop software because each of our retailers has their own environments. So there's a bit more complexity in terms of how we deploy software than maybe other organizations that tend to deploy this once and they're done with it. Kind of, we have to take into account that, you know, Japanese customers behave differently to American customers, and that depending on how sophisticated the retailer is and how much data there is already available there and what kind of constraints they have, the models have to be able to behave slightly differently. But we need to be able to build this once and then ideally deploy them to all the different areas and still have good quality results. So it is definitely a little bit different to the general way that I've seen machine learning done in yeah, previous experiences.
Yeah, there are so many constraints like that. Even, a single business will typically have those same constraints because of jurisdictional kind of data laws and, various kind of sub-entities within the parent company. So that's very interesting. And like, I guess, like, do you think there's so much hype around machine learning and AI. You just read about it in the popular press, you hear about it on the radio, it's on the television, it's in your face, right? In popular culture. Do you think it is in the mainstream in business? Do you think that's such a simple question, but how do you react to that?
So I think kind of there's almost two aspects to this, right? Like why isn't machine learning necessary? And I think kind of fundamentally, if we look at most of the organizations today or kind of the products that they sell, I don't really see a future without much more use of machine learning. Customers want better personalized experiences faster. And fundamentally, at some point, you can't staff that up by individuals, right? Like you can't hire enough shoppers to decide for you what you should be buying every single week out of a catalog of 60,000 products and bring it to your doorstep within a couple of hours. That's just fundamentally not possible. So I think there's a business requirement to get towards more automation and machine learning purely because of the demand from a customer perspective. And then similarly, you have the kind of your other organizations within your space, right? Like they're likely going to invest into this, right? Like it is very likely that at some point you will in some way be competing with big tech, and they have been investing into the space for a long time. So there's the competitive pressure and the customer demand. So I think organizations are more and more waking up to the reality that without machine learning and automation in some way, it's going to be really, really hard to find your space that allows you to still, yeah, operate profitably.
So what's holding them back? I mean, I totally agree. What's holding them back? Because you just I see, someone who knows what ML can do and knows what ML can't do. Just see so much opportunity. See, what do you think is? is holding a bit faster, more widespread adoption of this technology back?
So I think there's probably been a lot of hype over the last years around like AI can solve every problem. That I think in certain times wasn't particularly helpful, right? Like we know that there's a lot of AI solutions out there that aren't really delivering on their promises, and there's been a lot of over promising. And I think kind of probably a few organizations have been burned by having tried something that fundamentally didn't deliver. I think that's one reason. I think the other reason is that actually culturally that shift is quite significant. And that kind of shift has to happen. The cultural shift has to happen both on the AI professional side and on the kind of the other side of things. I remember when I started my career, like we were proud of how complicated the stuff was that we were building, right? Like we had hired lots of PhDs and stuff like that. But actually trying to sell something to someone by saying, look, our solution is so smart doesn't necessarily always work that well, right? Like you have to shift towards the look, my solution solves your problem so much better than something else. And here's all the value and stuff like that. And there's a little bit of learning that machine learning professionals had to do in that case. And then obviously on the other side, right, like if you look at many kind of traditional organizations, they've grown up being successful doing what they've done for a long time. So in the retail businesses, right, like a lot of the retailers were super successful because they knew how to manage averages and they knew how to manage kind of cycle times, right? So you had an average customer that was doing an average shop in an average store, and you would look at this every 6 months or something like that because your operations were super constrained, right? You didn't want to change prices every day. You couldn't change ranging in your stores every day because it cost a lot of money. And so they've become super successful in that space. And now making that shift towards the online world where you have to be super personalized and stuff can change all the time, you kind of have to get rid of averages because Ed has a very different shopping behavior than Gabriel. And Ed wants to make sure that he gets the stuff that he cares about, and that might be different to Gabriel. And at the same time, Ed wants that now and wants the changes now. I think that kind of requires a fundamental rethink. And that's not necessarily easy. And a lot of those businesses also have significant businesses that still make money in your ways, right? And that shift again isn't necessarily easy.
That's super interesting. And what do you think are the kind of foundational, I don't know what percentage of firms have a chief data scientist kind of role, but what do you think are I guess when you were ever considering moving to a new job, like what are the things, the foundational bits of infrastructure, culture, technology that you think are, ground zero for doing this stuff?
So it's probably around three dimensions. There's something around like structures and probably culture kind of sits a bit in there, right? Like the people aspect of it. So where where do you discuss data? Is that something that's kind of discussed in the teams, low down, in, if you want, in your organization, or is it something that's being discussed at the top table? And what kind of discussions is it about data? Is it purely around like, oh wow, we have a risk because something happened and we've had a data breach, or is it also about the opportunities? Therefore, how is your structure and how's the people? What kind of skills do you have? Is it data skills something that's required from everyone, or is there like a bunch of specialists that and it's their problem. Data people solve data problems, and data problems are there to be solved by data people. Then there's something around like processes and
So do you have an opinion on that? Do you have should you have an internal centralized data team that is like a kind of almost a shared service for every line of business, or do you make sure it's embedded with kind of, almost like a data scientist for every team? Or do you have any opinions on that?
so I think it does depend on the maturity and the setup of your organization. So if I look through my career, I've seen kind of this move where very early on, before data science was really a thing, right? Like they ended up being embedded because you just hired smart people who could solve a problem. They didn't have any bespoke tooling, they didn't have any bespoke skills. Then over time you realize, well, actually those people are doing something similar and you have them all over the place and you have a bit of a marketplace issue, right? You have smart people who can solve really complex problems, not necessarily sitting in the part of the organization where the biggest impact problems are. So you then went into the centralized approach where you then had bespoke ways of working, you had bespoke tooling, etc. But what you then ended up having as a problem is that it was actually really difficult for those people to deliver values quickly because they were getting quite far away from the implementation and from the teams. And I think now, and that's the way that we're running it, you're almost like in what we call central line management, but local task management, where you have a data science organization that is all part of the same kind of craft, but they are embedded within delivery teams so that they can really understand the local needs. And I think there's similar questions to be had around like how do you organize your data teams more broadly? Because you have a data science organization that is all part of the same kind of craft, but they are embedded within delivery teams so that they can really understand the local needs. And I think there's similar questions to be had around like how do you organize your data teams more broadly? I think you can't scale particularly well with a central data team. At some point, you run into problems. So we prefer to have teams that build the central tooling, and then kind of the rest of it, putting the data into that, is kind of distributed. But you need to make sure that you have really good best practices in place, and that you figure out, well, how does your data model add up and stuff like that. And so that kind of having autonomous teams that can move fast with enough central support, I think is at the moment the model that I believe works best if you have a more mature organization that is in general running technology that way.
Makes sense. I mean, you need that because without an investment in tooling and without an investment in those kind of central data resources, a lone data scientist in every team is just going to be, every single one's going to be reinventing the wheel. Every single one's
Yeah.
going to be not sharing that knowledge, right? So, yeah, so that's just so interesting from a cultural and kind of organizational perspective. What else do you think is like, foundational?
Well, and then the other two parts, and we've kind of semi talked about them already, is like process, right? So is your data science team separate, or is it part of embedded? And how does work kind of go from one part to the other? Is there a handover, or they all kind of, is it the same team developing, running, maintaining what you built? And then tooling. I think kind of for us, one of the things that we really want to get to is that the development and deployment of machine learning at Ocado scale is as simple as shopping online, because it has to be, right? Like the more tools we're going to build, the less time we can spend on trying to get to a point where it ends up being in production. And we need to be able to ship early and ship often so that we can really iterate on what we build and really learn what works and what doesn't work.
What are the most interesting trends in this field that are exciting you, and do you think will be the most impactful over the next few years?
I think the stuff that I'm most interested in at the moment is the discussions around ML ops. I think kind of DevOps made such a massive impact on software engineering more generally. Then there was something called data ops, which I think is still fairly kind of new as well. And then obviously ML ops as the aspect of how do you build and manage your machine learning algorithms. And I think that's going to become more and more complicated, right? Like as you have more models that are in production all the time, as you kind of need to manage model drift and data drift and all of that stuff, being able to be on top of that stuff without necessarily increasing the size of your organization, I think it's going to be super fascinating to try and figure out what's the right tooling that you need to put in place. How do you keep on top of your increasing data sets to measure that quality before it goes into it? Who's responsible for this? Do you put your data scientists on 24/7 support, even though you might have less of them, or is that something that software engineers do? How do you avoid handovers? Because handovers generally kind of create some sort of grumpiness in the teams and probably slow down your development process as well. I think that operationalizing it so that you can really put machine learning in all of the parts of the organization where it provides value without you having to build a insanely large data science organization. I think that's super interesting. I mean, obviously there's a lot of stuff also in, deep learning and stuff like that. And I think kind of the stuff that I'm interested in that space is actually almost more active learning. And how do you get on top of your data quality issues and make sure that you kind of find the right places and explore and kind of reinforce, I guess, like data collection and data validation in those specific areas.
That's so interesting that, yeah, I mean, because the rate of advance and deep learning is fascinating, and the fact that what is capable. But you picked your two most exciting things were active learning and ML ops. ML ops maybe sounds very dry, but like both of those things to me, active learning and ML ops, they're about agility. They're about
Yeah,
like, I have an idea, I want it in production, and I want to iterate and improve on that thing. And if I don't
yeah,
have either of those things, like a great ML ops framework or any ML ops framework, or an active learning approach, getting value, changing the system, improving it is just going to be a nightmare. you
yeah. I
know.
think kind of for me, a lot of the stuff that I think is interesting is how do you get to value quicker? Because I think only really that's really where the crux is, right? Like we're not doing ML because it's interesting. We're doing ML because it creates better customer experiences and ideally better business opportunities for the organizations that we work for, that we serve. And I think therefore that's where, in my view, the interesting aspects are right now. And this is the difference, I guess, like maybe with what you see a lot of in academia in terms of where their focus is. Most of the focus is on new algorithms. Well, actually, in businesses, the bigger challenge is probably data and data collection, data quality, and then, as we talked about, ML ops and that kind of area.
is one of the greatest kind of gaps. It's like academia is still obsessed in many ways with accuracy and what's ultimately possible in some sort of asymptotic kind of
Yeah.
notion, whereas business is totally mad about like time to value, agility, how quickly you can get the first version 1 into production, and how quickly you can get to version 20,
Yeah.
and that and it's just it's almost a chasm, it's just like totally different priorities, totally different needs and requirements.
Yeah, and how easy can you fix it if it goes wrong, right? Like how easy can you understand if a customer complains about not having had the right order? How easy can you improve it and explain to them around like, well, sorry, this is what happened, but it won't happen again.
Yeah, 100%. And how do you, I mean, this is the last kind of question, like, and it's a bit cheesy, but what do you see as the ultimate kind of evolution of how ML, and AI will work with people? Business is people doing stuff, right? And now it's kind of ML also doing stuff, technology doing stuff. How do you see this thing kind of panning out in the 10 to 20 year kind of timescale?
Yeah, so for me, I think kind of the reason why ML is beneficial, if we look from a customer perspective, I don't know if you've ever watched a parent trying to take a child through a supermarket. You can clearly see that they're not enjoying that journey, right? Like there's so much cognitive stuff that's happening. They're trying to keep their child quiet, and there's so much complexity of trying to make the right choices given all of the different, offers and all the products that are available there. And I think kind of the world has become super complicated, right? Both from an employee perspective and from a customer perspective. And machine learning can help make it simpler. Like if we can help you make the choices on your behalf that really kind of respect what you care about, but mean that you have less effort to do so. And similarly, if we can help automate it from a kind of business perspective to make the choices that make sense, that kind of trade off business requirements in the right way, I think that is super helpful because then a lot of our customers and our colleagues can focus on the more creative aspects of their job. So I think that's one thing where data science or machine learning will go a bit more is like that understanding of that. In my view, the most kind of rare resource you have in an organization is cognitive energy, and helping you optimize that is going to be really, really big. I think the second aspect of it is I think at the moment most of our machine learning models are kind of if you want single turn conversations with a retailer, right? Like, or with the organization, sorry, it's not just retailers, it's the same, to be honest, in media, right? Like I tell you, I'm bored, you show me a bunch of possible movies, I select one or I don't select one. We then have a separate interaction that's completely independent of that previous interaction. I think with stuff like voice coming around, we're going to get more and more towards a multi-turn conversation. And that doesn't have to be voice, it can be kind of other interactions, it can be kind of chat messages, or it could just be how you flow through a user interface. And I think that's going to be really interesting around how do we build true multi-turn conversations with with our customers. Like if you talk to friends or you say, oh, I'm interested in this thing, you then follow up on it. It kind of, there's a link, and that currently doesn't exist that much in
You
the
mean this
business.
is kind of like in statistics like Markovian, it's like I only remember the last state,
Yeah,
right?
exactly.
But we're at, the a true relationship, true loyalty is the whole history of that.
Where do you come from? Yeah, what
Yeah.
kind of what was your previous question? How did you interact with me beforehand? What did you tell me you didn't like that I can not show you in this next interaction with you? How do I just make your life so much easier so that your experience is really pleasant and as short as it has to be?
Great. Well, super great to talk to you today, Gabriel. Thank you so much for taking the time. Um, Thank you.
Thanks a lot, Ed. Always good catching up with you.
Cheers.